Hi everyone, welcome back to Research M421 Analytical Chemistry. We continue our learning on topic 4, trimetric analysis on the acid-base titration. In this video, I will explain about the quantitative analysis. The quantitative analysis, the goal is to determine how much the analyte presents based on volume of titrants. So it's a very simple formula that you will apply. You will apply the formula of mole. Mole is usual mass over molar mass. Molarity is mole per liter. So you're going to use these two formula to solve the problems in the acid-base titration. In the acid-base titration, you assume the A is the titrant. Titrant is the solution in the biorate. This is a titrant. B is the analyte. Analyte is the solution in the conical class that we add with in the indicator. So let's say we have a reaction between A and B. It produces a product. So we're going to use this relationship as well to do calculation for titration problem during the titration. MA VA over MB VB equivalent to A ratio B. So you have to remember this formula. So here is the question related to acid-base titration. You can read the question carefully. We try to solve it together. Even the answers is already given, we can try. Calculate the concentration of vinegar in a percent weight per volume. So it's asking you about concentration in weight per volume. For a titration of 25 ml of vinegar, which was primarily diluted 10 times, 25 ml equal 250 ml, reacted with 22 ml of 0.1 molar standard solution. So this one is the molarity of A, can be molarity of A, and also volume of A. That one is in the biorate, the titrant in the biorate. So this vinegar is the analyte of sample. Okay, so the volume is a volume V of vinegar, which was primarily diluted 10 times. Okay, meaning that at the beginning, 25 ml of vinegar put up in 200 50 of our volumetric flask, and then from here use for 25 ml used for titration. So it asking you what is the concentration of vinegar in weight percent per volume. So the volume, we know the volume because it's asking about this one. We know volume, we know 25 ml. Weight, we don't know yet. Okay, so we have to find out what is the weight of vinegar in the titration. So in order to know the weight, we have to calculate the mole. In order to know the mole, we have to calculate the molarity. So it's a very simple. It's back to M1 V1 over M2 V2 equivalent to A on D. Or use this formula. MA VA MV BV D. So first we write the balanced reaction equation. Because vinegar is acetic acid, CH3COOH. This is acetic acid. React with sodium hydroxide. So the Na will, so this one will be dissociated into CH3COO minus H plus Na plus OH minus. So Na will be react with acetic, and H plus will be react with hydroxide to form water. So when the acetic react with Na, we gain sodium acetate, and the hydrogen react with hydroxide to form water. So we have to balance the equation. Is 1 1 1 1. Okay. So so let's say this one is AA, and this one is B. So you can use this formula to calculate. So we know MA VA, we know A. We know VV, we have to find out ND. So MA 0.1 molar times 22.4 ml equivalent to 1. Why 1? Because this is 1. Okay, here is 1. And then okay, we use another way, because we is already level. A is acetic acid, B is the sodium hydroxide. So we can write Na, the thing that we want to calculate, times 25 ml of acetic acid equivalent to 1 divided by 0.1 molar with 22.4 ml. Also 1 because this one react with 1. So we can cancel the unit first. ml, cancel with ml. So you can calculate what is MA. So by using a calculator, you can calculate 0.1 times 22.4 divided by 25. So 0.0896 molarity. So from the molarity, you can calculate a mole. Mole is because we know molarity is mole per liter. So from here you can calculate the mole molarity times volume in liter, meaning that 25 ml divided by 1000, 0.025 liter. So 0.0896 times 0.025. So 0.00024 mole. So from the mole, you can calculate the mass. So the mass is mole times molar mass for acetic acid. So acetic acid molar mass is, you can calculate using the periodic table, is a 60 gram. So it's a 60 gram per mole. So you can cancel the unit. So this one is gram per mole. So 0.00224 times 60. So mass is 0.144 gram. So the question is asking the concentration. So the concentration and the concentration, I write it here. Okay, concentration weight per volume 0.1344 gram. Volume is 25 ml times 100. So 0.344 divided 25, 0.1344 divided 25 times 100. So 0. just now? 0.5354%. Width per volume. Okay. So, what is the answer given? Why the answer 5.4? Something wrong. Okay, we can double check this one. Mole 25, 22 point 25 ml, 1, 0.1, 22.4, okay, 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 0.0896 is the same. Yeah, it's same with us. Okay, we also get the 0.0896. Mole is okay. The mole 0.00224. 0.00 here is a 0.0. What's wrong with this one? So 25 ml divided 1000, 0.025 times 0.0896, 0.0224, meaning that this one is wrong. 0.00224 mole. So this one 0.00224. So times 60, 0.1344 gram. So this 0.1344 gram divided by 0.1344 divided by 25 times 100, 0.54%. Okay, so since goes to our calculation. Okay, it's the same. So you have to double check. Sometimes the answers given wrong, so you have to double check. Okay, let's try another example. In this example, a sample weighing 0.8365 gram of diprotic acid. Okay, this one gram of diprotic acid was dissolved in 75 ml. Indicator was either in that solution was titrated with sodium hydroxide. So this is a titrant. 35.35 ml of sodium hydroxide was needed to reach the end point. So molar mass of acid H2O, AH2A, 150 gram per mole. Calculate the molarity of the base. Okay, it's asking you what is the molarity. What is the molarity of sodium hydroxide? Volume, we know the volume is 35 ml, but molarity we don't know yet. So here we given a gram, so we can calculate a mole. From the mole, we can calculate the molarity. And then the diprotic acid, we know the volume is 75 ml. We know, and molarity also we can calculate from the mass into the mole into the molarity. So first of foremost, you have to write the valence equation. So this valence equation a bit simple, but you can write the full valence equation. If you not understand this one, you can write it like the protic acid is way to write here H2A plus sodium hydroxide, and then produce what? So we know here should be H plus, A2 minus, N plus, OH minus. So we know H2O is one of the product. H2O2, so this one should be 2. So oxygen should be 2, and plus Na, Na2A. All right. So yeah. So this is complete balance equation. So if you want to say this is A, this one B, so you can use the formula MA, A, and B, volume B. So you have to take care or careful with the ratio 2 with 1. Okay, so this one is A 1 over 2. So we have to, as we mentioned just now, you have to calculate the mole first and then to the molarity. So what is the mole? I think I want to write it here. Okay, mole of acid 0.8365 gram divided by molar mass. We know the molar mass 150 is given. So when we use the calculator, 0.8365 divided 150, you get 0.00557. So this one is goes to 0.005577 mole. So molarity is a mole per liter. The volume is 75 ml. So in liter, 75 ml divided by 1000, 0.0075. So 5.5767, 10 to the power minus 3 divided by 17.5 divided by 1000. So 0.0434. So you get this one. All right. So if we write the valence chemical equation just now, we know MA VA over MB VB is 1/2. So we have to calculate the what we want to know the molarity of B. Okay, oh my god, sorry. We want to know the molarity of this. Okay, so MAVA, I write it here. So MA is 0.00566 volume. I can use 75 ml. 1. And then we want to know MB. What is the volume of sodium hydroxide? 35 ml over 2. So you can use your calculator. 0.00577 times 75 times 2 divided 35. So the MB, why the MB? What's wrong with mine? Okay, it's a wrong one. Idea. The molarity, it should be 0.0744. The molarity of, so 0.0744 times 75 times 2 divided 35. So in the molarity of sodium hydroxide is 0.3157 m. Okay, it's not really different with the answer given. So what is the question? It's asking what is the molarity of the base sodium hydroxide. Okay, we've done that one. So now we are moving to our next question. Okay. The next question is asking you a sample of sodium hydrogen carbonate, sodium hydrogen carbonate was tested for purity. So tested for purity. Purity normally and percentage using the following method. So 0.4 gram of solid sample was dissolved in 100 ml of water. So this one 0.4 gram in 100 ml was titrated with, so is titrated with what? Hydrochloric acid with molarity of 0.2 molar using methylene blue, methylene orange is the indicator. The volume of acid required for the complete neutralization is 2375 ml. Okay, so we have to calculate the purity. So meaning that the purity is this is the mass. What is the purity? So we have to calculate what is the mass of the real mass of sodium hydrogen carbonate react completely with 23.75 ml molarity of 0. ml of 0.2 molarity. So the purity X 0.4 gram times 100. So we want to know the mass of sodium carbonate neutralized. So first we have to write the equation for titration. So equation sodium hydrogen carbonate plus sodium hydroxide. So we can know sodium we know the equation is sodium chloride. Sodium chloride. HCl is not NaHO. It's HCl. Sorry, I'm wrong. It's sodium. It's HCl. So sodium chloride plus H2O plus CO2. Okay, is it balanced? Sodium, okay, chlorine, okay, hydrogen 2, CO2 3, okay, balance. So sketch the label titration curve. So titration curve, pH, and then volume, acid, added. So we know this one is the strong acid with a weak base. So strong acid meaning that the equivalent point should be in this case less than 7. So equivalent point pH less than 7 because it's strong acid. Okay, so see this one. All right. So determine the purity of sodium hydrogen carbonate in the sample. As I said just now, you have to calculate the mass of sodium hydrogen carbonate react with 23.75 ml of 0.2 molarity. So we use a same formula, MA, VA, A, MB, VB, B. Okay, let's say this one is AA, this one is B, B. Yeah. So sodium carbonate. So this one is VA. We have to calculate the molarity. From the molarity, we can get the mole. From the mole, we can calculate the mass. So this one is MB. This is BB. All right. So yeah, maybe we can write it here. So MAVA, MA, the things that we want to calculate, MA. VA is 100 ml. So it's 100 ml. The stoichiometric ratio 1 to 1 should be 1. And then NB 0.2 molarity, volume 23.75 ml. So stoichiometric 1 to 1. So you can cancel the unit and then you can calculate using calculator in order to find the MA. 0.2 times 23.75 times 1 divided by 100. 0.0475 m. So from the molarity, we can calculate the mole. So mole is molarity mole per liter times volume. What is the volume? Just now is 100 ml. So 100 ml in order to get in liter divided by 1000, 0.1 liter. So cancel the formula, cancel the unit, and then 0.0475 times 0.1, you can get the 0.00475 mole. So from the mole, you can calculate the mass. Mass is mole times molar mass from the unit of mole over molar mass. So the mole 0.00475 mole times what is the molecular mass of the sodium hydrogen carbonate. You can calculate using the periodic table, but I just use given 84 gram mole minus 1. So you can cancel the unit. So now it becomes 0.00475 times 84, 0.99 gram. So we want to know the here we want to know the percent purity So 0.399 gram over 0.4 gram times 100. So over 0.399 divided by 0.4 times 100. 99.75%. So we can check with the answer given. Yeah, 99.75%. All right. So I think it's all for this video. So we see you again on the next video. We will learn a little bit on back vibration. Okay, thank you very much. Bye bye. See you again on the next video.